Hello dear students, in this video we have to use Euclid's division lemma to represent any number in the form of any other number. What is given in this statement? Use Euclid's division lemma to show that square of any positive integer is either of the form 3m or 3m plus 1 for some integer m. In this question what we have to do? हमें यहाँ रिप्रेजेंट करना है, यूज करना है यूक्लिड डिवीजन लेमा का और उसका यूज करते हुए दिखाना है कि हम किसी भी पॉजिटिव इंटीजर के स्क्वायर को 3m और 3m प्लस 1 की फॉर्म में रिप्रेजेंट कर सकते हैं जबकि m कोई भी एक दूसरा इंटीजर है. नाउ व्हाट वी विल डू, वी विल यूज यूक्लिड डिवीजन लेमा. देन व्हाट वी विल कंसीडर, लेट a be any positive integer. What we have to take? Positive integer, and b is equal to 3. We choose b according to number which are given in statement. Then by Euclid's division lemma, Euclid's division lemma, a is equal to bq plus r and r less than greater than equal to 0 and less than b. But what is b? 3. So a is equal to 3q plus r, where r greater than equal to 0 less than 3. That is r can equal to 0, equal to 1 or equal to 2. When if r is equal to 0, or you can take for r is equal to 0, a is equal to 3q plus 0, means a is equal to 3q. But what we have to do? Square of any positive integer. So we will do square in this question. On squaring both sides, when we do square, we will get a square is equal to 3q whole square, means a square is equal to 9q square, but we have to represent it in the form of 3m, so we will take 3 common and it will become 3 into 3q square, and we can rewrite is a square is equal to 3m, where m is equal to 3q square. We can replace this by m. Now for r is equal to 1, a will become 3q plus 1. Now on squaring both sides, we will get a square is equal to 3q plus 1 whole square. Now here we will use a plus b whole square identity. Using a plus b whole square, it will equal to a square plus b square plus 2ab, and it can be written as a square is equal to a means 3q and 3q square means 9q square, b square means 1 square means 1, 2ab, 2 into 3q means 6q. Now on rearranging, we will get 9q square plus 6q plus 1. Now 3 is common from these two. We have to represent it in the form of 3m. We can take 3 common from these two terms. 3q square plus 2q plus 1. Then a square is equal to 3m plus 1, where m is equal to 3q square plus 2q. We can take this in the form of integer. Now we have to check for 2. So for r is equal to 2, a will equal to 3q plus 2. On squaring both sides, what we will get? a square is equal to 3q plus 2 whole square. Now using identity a plus b whole square, and it is equal to a square plus b square plus 2ab, or you can take 2ab in between. Now a square is equal to 3q square means 9q square, b square means 4, and 2 into a, 2 into a means 2 into 3q into 2, 2 into 3q 6q, 6q into 2 12q. Now we can rewrite it as 9q square plus 12q plus 4, or 4 can be written as sum of 3 and 1 means 3 plus 1. Now 3 is common in these three terms, so taking 3 common, what will left? 3q square plus 4q plus 1 plus 1. So a square is equal to 3m plus 1, where m is equal to 3q square plus 4q plus 1. So what will be our next answer line? So square of, and the, yes, look, it is in the form of 3m, it is in the form of 3m plus 1, it is in the form of 3m plus 1. So square of any positive integer is either of the form of 3m or 3m plus 1. We have to write this answer line. So square of, and you have to write it full, of any positive integer is either 3m or 3m plus 1. You have to do this question like this. If cube is there, then we will do cube. If simple statement is given, then we will do it up to this point. This type of question is important. You have to revise all questions of this type.